Hello and welcome back to the second lesson plan project that I have for this semester. I'm sure you already know me. My name is Aurora Aldridge, and I am doing the lesson plan about the garden. This one is about fractions and conversions, so let's get into it. The goal is to connect the prior knowledge and set a real-world context to this information. So, let me get my pencil going. I'm going to start with the question. Who has ever helped in a garden, or what do we use a garden bed for? Just to start the conversation, get some real-world connections with the lesson before we start. Before that, we get into it, I'm also going to go over with the class about how to find the area of a rectangle, just expand on their prior knowledge. We all know that it is length times width. Okay, so the problem is a garden bed is 3/4 of a yard wide and 2/5 of a yard long. So this would be the 3/4 side, and this is the length. So this would be the 2/5. And again, my penmanship isn't the best, so that's a 5. I apologize in advance. Okay, so I'm gonna explain to the students about how gardeners need to know the area to plan for how much soil, mulch, and plants they have for their garden in real-world experience. So then we will go into the direct instruction portion. I need to show the concept with the visuals and connect it to the algorithm. So again, we're going to be using the good old area model. We're going to draw a rectangle on a chart paper, and we're going to divide it into equal parts. So this doesn't have to be exact, but it's easier to do this on grid paper, just so that way they have a better idea of, it doesn't have to look perfect. As you can see, I am quite the Picasso over here, trying to just do a rectangle. So this side is the 2/5, and this side is the 3/4. So we are going to vertically get it into 4 equal parts and shade it for the 3/4. So, hold on. Okay. So it would be about 3 spaces each for it to be, there we go. Okay. So we're going to shade 3 of these parts. And again, it doesn't have to look the best, it just has to get the point across. Okay, so that is the vertically shaded for the 3/4, and horizontally into 5 parts, and we need to shade it. I'm going to switch to a different color so that way it's easier to see. I think red would do the trick for this. So there's 1, 2, 3, sorry, 4, and 5. Okay, and we're gonna shade 2 of these 4 2/5. So again, it doesn't have to be the best, but we're just gonna shade 2 of these rows with red. Okay, so the ones with the black and red overlapping are what we're gonna be paying attention to. It's a little hard to see. Again, I'm doing this on my computer, so if I had physical tools, it would probably be a lot easier to follow along. But we'll have 6 boxes that are shaded together. It's hard to see with the proportions on this graph, but they are 6 boxes. And out of the 20 total boxes that we have here, that is 6 out of 20 that are shaded together, right? But we can simplify this. So we can divide this by 2. So 6 divided by 2 is 3. And 20 divided by 2 is 10. So this is what we get right here. Each part of the grid shows a fraction of a yard, and they overlap, shows how much of the garden is covered when we multiply the fractions. So let's try this with a standard algorithm. Let me just clear this off. Okay. So again, it's going to be length times width. You know what? I'm going to stay to a different color so we can actually see this. Okay. So we have our fractions that we need to write out. 3/4. And we also have 2/5. Okay, so we are going to start multiplying, but it's easier for that to happen if you write it out with one on top and one on bottom. It's a little easier to get the point across, but it just depends on the preference of your students. Whatever works best for them, that's what you should roll with, for sure. Okay. And again, I do apologize for my handwriting on this. Okay. So, we're going to multiply the top numbers. So, 2 times 3 is 6, right? So, we'll just pop that over here after the equal sign. 6 is our numerator for this. 4 times 5 is 20. And just like before, we get 6/20. But it can be simplified, so 6/20 divided by 2. Hold on. It's supposed to be a division sign. I'm sorry. Not that great with managing this app yet, so that's a division sign. It's supposed to be. So, divided by 2. 20 divided by 2 is 10, so that will be our denominator. And 6 divided by 2 is 3. And just like before, we have our magic number of 3/10. We solved it using the area model and an algorithm. However, we can do some guided practice now that we have this problem done and we got the thinking juices flowing in the kids' brains. So this is going to be more like a guided practice portion of the lesson plan I wrote. I'm going to give students some grid paper just like this, and I'm going to have them recreate an area model. It could be the same problem. They can just do it with a different method. That's totally fine. You can do another number, but we were going to do 2/3 for this side, and 1/2 for this side. Okay. And we will have them solve this with the area model and the algorithm on their own without my help. If they do try it a few times and just can't get it, then I'll give them a little nudge in the right direction, but I want to focus on getting confidence in their academic mathematics skills. So I believe guided practice is quite important to have during a lesson planning. But after the guided practice, I would have them go to a reflection and discussion. Just talk with the class. How does the shading of our area models when we do these rectangles to find the yard and fraction conversions of the garden beds, what do the shaded portions represent in the multiplication problem? So if the red and black or blue overlap, what would that represent? And just kind of have them answer that on their own and expand on it if necessary. I would also go over, why do we multiply the tops of the top to the top and bottom to bottom, numerator to numerator, denominator to denominator? Why are we, it's because we're taking parts out of parts, and we just want to make sure it stays consistent across the board. So when we put it all together, we have a more accurate response. I do wish to encourage the students in any way I can. However, fractions can be a little hard to understand at times. So if my students were having difficulties, I might have cutouts and props they can manipulate and have a more concrete sense of what it means and what it represents. The assessment, the exit ticket I would do for this lesson would most likely just have them create their own garden and, like their dream garden. What would your dream garden be? What flowers would it have? Would it have roses? Would it have violets? How much soil would you need? And again, I'm so sorry about my penmanship. I'm trying my best here. Okay, so roses, soil, all of that. How big would they want it? Would it be just for a little part of their yard, like a little square? Or would it be around their entire house? What would that be? I want them to really think about this. And it doesn't have to be pretty flowers. It can be a vegetable garden or a fruit garden. Totally up to them. Excuse me. Sorry about that. But, it could be around their entire house. It could be even like a garden in their car. Or a garden to keep in their apartment on their window. Like a really small one on the little windowsill right there. I just want them to kind of have some fun with this and, see what they come up with. But I do want them to just find the measurements for their dream garden and, find the answers, and that's their exit ticket. I'm trying to get a little more creative with my approaches. However, it can be a little hard with math, so if you have any suggestions on how to make this lesson plan a little more engaging, I think any advice or input would be greatly appreciated. I don't think many kids really appreciate the the wonders of gardening as much as someone my age would. So I think I might have to adapt the problem to something they might actually have a little more relatability to. Maybe I could change it to how many Legos would it take to make this picture frame. Something similar to that, but a little more relatable and concrete to them. I think that would probably be a good suggestion for me. So that is my little problem solving for this garden problem. Little mini lesson plan mock. Thank you for watching, Professor Jody and all the random people on YouTube. I know this one's shorter than the last, but have a little more practice with this one, so went a lot smoother and quicker this time. Thank you for watching, and see you next time.